met hierdie vraag is daar 75 kg massa wat aanvanklik in rus is, wat opgetel word 12 meter teen 'n konstante versnelling van 0,65 meter per sekonde. So it's a block being picked up at a constant acceleration of 0.65 meters and it starts from rest. Okay, now they ask us, draw a labeled free body diagram for the load while it moves upwards. Okay, so what forces is acting in on this 75 kilogram block? Gravitational and? No, normal. Tension. Yes, so the first question, 13.1. Let's see. 29? So we have tension going upwards and gravitational force pulling it down. Okay, that's an easy 2 marks. Then they ask us, name the non-conservative force acting in on the load. Okay, do you remember the difference between conservative and non-conservative forces? Okay. Yes, it's switched around. So our non-conservative forces is contact forces and our conservative forces is non-contact forces. So a non-conservative force, so a contact force is what? Okay. So ons nie-konservatiewe kragte is kontakkragte en ons konservatiewe kragte is nie kontakkragte. Okay, so daar is 'n goeie manier om dit te onthou. Ja, dis tension, dis spanning. Okay. Yes. Okay, so hulle sê ignoreer ligweerstand en rotasie effek en die massa van die tou. Nee. Okay. Okay. So our non-conservative force is the tension of die spanning in die tou. Reg? Okay, want dit is 'n kontakkrag en die enigste ander krag daar is gravitasiekrag. En gravitasiekrag hoef nie aan jou voorwerp te vat om op hom in te werk nie. So gravity is a conservative force, okay? Now question number 3 asks, calculate the work done on the load by the gravitational force when the load has reached a height of 12 meters, okay? So how are we going to do that? They want us to calculate, this is number 3, the work done by our gravitational force. Do you guys remember the equation? Yes. So in this case we will have Fg delta x cos theta. So dis ons krag maal ons verplasing maal die kos van die hoek tussen die verplasing en die rigting waarin die krag inwerk. Okay? So Fg is easy to calculate. Mass times gravitational acceleration, massa mol, gravitasieversnelling. Okay? Delta x cos theta. Okay, so we have a mass of 75, G is always 9.8, and delta X is, in this case, 12. And what is the angle going to be?
Okay, wacht, hij beweegt op en af.
180 grade. Okay? Ons krag waarna ons kyk beweeg afwaarts. maar ons bewegingsrigting is op. Soos 180 grade. Is julle almal reg daarmee?
Ja, wat is die antwoord? Ons spreek ons uit. Nou, verstaan. Minus 882. Wat is 'n negatiewe
So this is negative work of negatiewe arbeid because the force is acting in the opposite direction of the movement. Die krag werk in die teenoorgestelde rigting as die rigting waarna ons beweeg. Okay, julle verstaan dit? Reg daarmee? Okay, nou 13.4. Stel die arbeid-energiestelling in woorde. Okay? State the work energy theorem in words. That is a definition. That is something you will have to papegaai leer. Okay? So you can get a free, easy 2 marks. Okay? Let's see. Okay, this is the Afrikaans one. The network done on a object is equal to the change in the kinetic energy of the object. Okay? Die netto arbeid verrig op 'n voorwerp is gelyk aan die verandering in kinetiese energie van die voorwerp. Okay, so that is 13.4. Now 13.5. Okay. Gebruik die arbeid-energiestelling om die spoed van die vraag wanneer dit op 'n hoogte van 12 meter is te bereken. So use the work energy theorem to calculate the speed of the load when it is at a height of 12 meters. Okay, so I'm going to show you how to do it in a way I haven't done it before. Okay, so our work energy theorem, this is 13.5. So our work energy theorem is W is equal to delta EK. Okay, arbeid is gelyk aan die verandering in kinetiese energie. Dan is die arbeid-energiestelling. Okay, so daar is, laat ek net vinnig kyk. Ja, jy kan die nie konservatiewe arbeidsvergelyking ook gebruik. Maar hulle vra vir die arbeidsenergiestelling, so ons gebruik hierdie een. Okay, so waar was ek nou? Okay. So another way to calculate the net work done on something, right, is by using the net force times delta x times cos theta, which will be equal to half mv final squared minus a half mv initial squared. Okay, so what variables do we have? Okay, we have our height of 12 meters, okay, which is the same as delta x. Our mass is 75 kilograms. Our acceleration is 0.65 meters per second. Let me just see. Yes, and our initial velocity is 0, and what we want to calculate is our final velocity. Okay, so dit is al ons veranderlikes wat ons het. So ons kan sien, ons het VI, ons het M, V finales wat ons wil uitwerk, ons het M, theta kan ons uitwerk, delta X het ons het nie F net nie, okay? So what does Newton's second law say? Equations. Okay, what is Newton's second law's equation? Yes, F net is gelyk aan ons massa maal ons versnelling. And now when we look at our table of variables, we can easily see we have our mass and we have our acceleration. So we can substitute that in. So we have 75 times 0.65. That gives us an answer of 48.75 newtons. Okay, now because we calculated F net quantity, okay, omdat ons F net uitgewerk het, kan ons F net daar gaan invervang. Okay, so this is something we haven't done before. We haven't used the F net equation, right? Okay, so let's substitute that in. Okay, we substitute it over there. And we have 48.75 newtons. Or delta X will be 12 meters. And now we get to the angle. Okay, ons hoek. In watter rigting gaan ons hoek wees? Gaan dit 0 of 180 grade wees? Want nou moet ons dink, in watter rigting is ons netto krag? Okay, so we must figure out in which direction our net force is going to act in on. Yes. No. Okay. So if we look at this picture, right, it's moving upwards. Okay. So that must mean the upwards force is winning this little game, right? Because it is moving upwards. Okay. So our net force will be in the upwards direction. Okay. Then our angle will be 0 degrees. Okay. And then we do the second half of the equation, 75 times v final squared minus 0 squared. Hoe bedoel jy? Ja, dit is die een wat ons gebruik, want w net is gelyk aan hierdie, as ons in ons notas kyk. Iewers hierso het ons arbeid gedoen. Okay, somewhere in here it says that our net work is equals to our net force times delta x times cos of theta. Okay, so that's how we get from this to this. Hoe bedoel jy?
Wat kry jy? 15,6.
Okay. So this, through some nice math, gives us a final velocity of 3.95 meters per second. Okay, not so bad, right? Okay, I like the vertical movement questions. Now we're getting to, okay, wait, just let me show you as well. Okay, 'n tweede manier om hierdie som te doen is to calculate F net from the start. This is mass times acceleration. Or two forces working in, ons die twee kragte wat ons inwerk is gravitasiekrag en spanning. Ons vat opwaarts as positief. Dan is dit ons spanning minus ons gravitasiekrag is gelyk aan ons massa maal versnelling. And then we can substitute, this is 75 times 9.8 equals to 75 times our acceleration of 0.65. And we get a tension of 783.75 newtons. Okay. Now we can calculate the work done by our tension force. Nee, moenie worry nie, dis 'n tweede manier om hierdie vraag te doen. Okay, so ek wys net vir julle nog 'n manier om die vraag te doen. Okay, so nou kan ons die arbeid uitwerk wat deur ons spanningskrag uitgevoer word. En dit is bloot eenvoudig ons spanningskrag, maal ons verplasing, maal die kos van theta. Ons het nou net uitgewerk is 783,75 maal 12 maal die kos van 0 of 180, want het werk met die spanning.
Span 180.
0.
Nee, net doen ons anders.
No, you'll get the wrong answer. 0 degrees, because the tension is upwards, ons spanningskrag trek op en ons beweeg opwaarts. Okay, so is 0 grade. Yes, like it was, well, yeah, for the work done by our gravitational force. Okay. So hierdie staan gelyk aan nou kan ons die ander werksvergelyking gebruik. We can use the other equation. The work done by our non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Okay? I'm just showing you can do it in a different way. Well, you never know. Yes, so our only non-conservative force here is our tension force. So the work done by our non-conservative forces is equal to the work done by our tension force, which is 9405. Yes. And then we have our change in kinetic energy, so I'm just going to fill it in so long. So it's a half.
Altyd hierdie opsie kan gebruik, want wat as al nie van ons versnelling gee nie? Dan kan ons nie hierdie, dan kan ons die F net bereken nie, dan kan ons dit nie, want dan ons weer onbekend is, dan kan ons nie dit gebruik nie. Dan moet ons die ander gebruik wat ons
Yes. Wel, met die ander een het ons ook ons Newton 2 gebruik met ons versnelling, reg? So dis dan gewoonlik wanneer jy of twee vergelykings gaan moet hê, waar jy jou spanning, ja, hulle gelykstel aan mekaar en die spanning en jou versnelling bereken. Okay, and this will give us the same final velocity of 3.95 meters per second. Ja. Yes. Okay, so okay. Ons het twee vergelykings. Ons het die arbeid-energiestelling. So ons het hierdie vergelyking. Okay, dan 'n ander manier om ons netto arbeid uit te werk is met hierdie vergelyking. Bye. Okay, so we substitute this equation into here. Something you have to figure out. It's something where you have to look at what they give you and what you can do with it, right? So a good idea is if you have height, okay, maybe you should look at the equations with potential energy in it, okay, because our potential energy is going to change. If they give acceleration, look at using Newton's second law.